So we are going to talk a little bit about their observability, which I think is very important for a lot of applications, but for databases, it's very important in particular. Now, if you would ask what is observability, right, you want to learn about it, you probably can go to one of your favorite chatbot, ask a questions, you'll get something something like that, right, or maybe a few pages more. But you know what, if you really want to drill in there, or like understand or explain observability to let's say your child, I also like this analogy, right? If you ever been in an airplane, peeked into a cockpit, you will see what there are a lot of different dashes out there and another instruments which show us all about how things operate in a plane, right? And this kind of observability, because everything is being measured, recorded, and analyzed, is important part about how the aviation is so safe, right? If you think about that, that's like a very extreme, complicated piece of equipment, flying high above the earth, right, and doing that very, very reliably compared to, well, reliability of the average software out there. What that also shows us, I think, is what observability can be complicated, right? While observability on a plane is awesome, it also requires pilots a lot of training to be understand and react and so on and so forth, right? Which is not always adequate for a lot of modern developers, which see the kind of observability is not as their main job and would like to see something more simple. Now, the other thing which is interesting is what has been happening with application development. Now, I am somebody who got involved in this space in early 2000s, late 90s, and at that time, we have a lot of systems that are quite small, right? Like you have maybe your application server, database server, maybe a couple of them. And it was very easy to pretty much open your SSH shell in all the servers you want. If something happens and you write your boss complains or to alert comes, you can often just tail a couple of logs or run a couple of shell commands and figure it out, right? Of course, that doesn't work anymore with our new application scale, which are much more complicated, have much more moving parts, and that is why now the observability have been developed in very large, complicated industry. Now, if you look at observability, it actually has a number of areas, right, where it can benefit us with applications, right, ranging from availability to all the way to security. If you think about like two areas, what we see with observability, I think it's good to think about that in both proactive and reactive context, right? Reactive is troubleshooting and optimization. Things are down, or things are slow, something is not working, I need to figure things out, and that's observability can help us with. Reactive is, so proactive is, on the contrary, hopefully you can learn about how system behaves to prevent the problems before they happen, or maybe you can spot slowdowns before they start to be impacting users and so on and so forth. Another important part which plays with observability is alerting, right? We obviously want to make sure if things don't work, it requires us attention, observability system can go ahead and inform us. When you talk about observability, we often can talk about pillars of observability. There could be 3 pillars of observability. I've seen people mention even 5. I focus here on 4, just for very simple and silly reason is I wanted to create a LinkedIn poll, and that allowed us to only up to 4 choices, where I would ask this, sort of like a trick question, right? If you have to choose one, what that would be. Of course, you don't have to choose one, but I think it gives us a very good idea about, hey, what is the most usable thing, which is, I would agree, the metrics and logs. So what are metrics are? Well, metrics are basically some measurements, right, we capture from a system, right? Like if you think about that dashboard of an airplane I showed you, it has a lot of metrics visualized, like your airspeed, your altitude, and number of fuel you have in the fuel tanks. All those are metrics which show us a lot of important stuff about the systems, and they're very nice because they're simple to understand, right? And they can show us a lot of the basics stuff without overload. For modern systems, you often have thousands of metrics which can be sampled every second, and kind of if you look at some dashboards, you may be looking at also many hundreds of graphs on many dashboards, right? That's what drives a lot. Now, logs are where the application would log certain information about its operation. You can have logs ranging from, let's say, error logs where only errors are logged, to all the way to debug log, which can be very detailed about everything which is kind of going on. And what often we would use logs and metrics together, where metrics may tell us, oh, look at that, I have, I don't know, let's say increased error rate, right? Or increased query response time, and then I can go into the logs and get some more details out there. The challenges with logs is often they are quite expensive to produce and store, right? They take more space than metrics, so often we don't log everything. They have to be kind of very selective. The other newer kind of extension of sorts for logs is called distributed tracing. The thing about the logs, they're local for every application instance, where we often would look in that complicated environment to be able to see, okay, this user request, which was kind of executed on all those different subsystems, what happened to it, right? If a failure or response time increase happens, where it come from, and that is what allows by tracing, right? So here's example what distributed tracing can provide. As you can see, the single request that hits the different microservices, right? It can see you where response time comes, right, and how that's aligned on the timeline, because things are executed in parallel, right? And you can see where errors are. And the last one to mention here is a profiling. The profiling allows us to see where CPU time, walk log time, maybe even kind of memory is used up in your application. And that is very helpful because that is often talks to developer about the things they understand and they control, right? For example, you can say, hey, in your program, right, there is a lot of CPU time spent in this function. Go figure out how to optimize it. Bubble sort is not always such a good idea. So that is example of one of a common visualization of profiles with that flame graph. Yeah, it's kind of resolution here is kind of funny a little bit, but you what there are actually like some function names out there. And what we also provide, I think, is a very cool way to visualize that is often you want to focus on the differences. What is the difference between your kind of normal case and then your application starts to show excessive, CPU usage, right? Where you can see in this case where red areas are where more CPU usage happens, green where it's less relative to the normal case, right? And gray is just usual. Okay, now if you look at observability, the question is how do we get all that of a data to display, right? And if you think about the airplane analogy once again, right? It has a lot of instruments placed everywhere in every single widget of that airplane to supply that data, and that is the same in your application. Now, in software part, though, we have two types, like a general types of instrumentation. One is a static instrumentation, right? Where you basically put the code to increment the metric, or maybe emit the log, right, or something like that, right? And it's awesome. It's kind of simple. If you think about something like Linux, procfs, right, it gives us a lot of information, right, which is out there, available all the time. We can rely on it. Very cool. But you also cannot really instrument everything. It can become very, very expensive, right? Very, it just becomes very impossible very quickly, right? And that is where dynamic instrumentation is helpful. Then you can say, hey, the application frameworks allows us to attach to any portion in the code and measure whatever you want to do, right? Hey, we can look at this function, I don't know, let's say, and log every call of it, or put the, latency histogram and so on and so forth, right? And that is the tools like a dtrace and eBPF, which is the main one which is used those days are using. Now, eBPF. eBPF name comes from extended Berkeley packet filter, though right now we don't really talk about that name as much, because it's kind of eBPF evolved from solely firewalling environment. And the good thing about the eBPF is it allows us to have a lot of powerful implementation, but it's also fast and it's also safe. For example, there have been some solutions for Linux kernel instrumentation which would require you to insert in some additional instrumentation model, right? Well, and if there is a bug, you'll have a kernel panic, and so you don't always want to do that, right? eBPF is designed so those things do not happen. Now, to learn more about eBPF, you can also check out the website, which I think is absolutely awesome. It's like one of a very nicely illustrated technology websites. Okay. Now, if you look at simplifying observability, right? What do we really want for our application on very high levels, right? And that would be, we want to have our most important SLIs to be within SLOs, right? What does that mean? Well, that means is what we want to have our service level indicators to be within service level objectives, right? Within those parameters that would be, right? Again, sort of very similar thing. If you look at the airplanes, you often can say, hey, you guys, we need to have our airspeed to be here, altitude being there, right? And if plane is flying too low, right, then you would get the alerts popping up and so on and so forth, right? If you look at the application, for a lot of them, the most important of them can be summarized as this, like, hey, it's rate of requests, right? How much work the system is doing, right? Same as your engine power, right, or something. Then they are looking at the availability, right, which is often defined as error rates. If you look at requests coming in, how many of them are completing successfully versus erroring out, right? And then often the third one between say, hey, we want system to work and work, system to do the work, works reliably, and we also want that to be fast, right? For this, we are looking about request latency, right? And that is where we often want to make sure we have a distribution, because just looking at the averages is not very helpful. Now let's talk about the challenges which exist often in their observability. One is observability can be hard to deploy, right? You can have sort of like a too much effort need to be done for tune install, connect, right, to everything. Especially that applies to some of the older systems which have not been built with observability in mind, right? Maybe you have some application which comes from a third party, right? Or maybe something was built ages ago, right? And you don't have a lot of team to maintain that anymore, and so on and so forth. It also may be hard to cover all the infrastructure, because you can see, especially for applications who've been out there or for companies out there for a long time, they can have everything saying, hey guys, we still have something which is running on the bare metal, if not mainframe, and all the way to some sort of that, like a serverless or cloud native applications, right? Some observability systems may not cover all of that. And what that gives us is sort of like a Swiss cheese of observability, right? Where you can say there are certain things which are very solid, very well instrumented. If problem is out there, you can find it. But there are some holes where if a problem happens out there, there is nothing you can see. We also can have solutions which are hard to use. We can have overwhelming amount of data, but which is kind of hard to understand. And for that, I think it's very interesting, right? If you look at PMM, the tool I mentioned we have at Percona, if you go talk to some DBAs, especially which experience that, and say, oh my gosh, this is so awesome. There's like so many of those kind of graphs, and it's kind of really instruments every system in a detailed system. But then if you look at to some, non-DBA, somebody say, well, what the hell is all of this, right? I mean, just tell me what to do, right? I don't need all that kind of, mumbo jumbo graphs and whatever, right? And I think, to me, this is kind of interesting about how different systems evolved over time, right? I mean, did you guys drive like the cars in, I don't know, in 80s, right, or 90s, right? A lot of the old cars would have a lot of things out there. Hey, here is your, generator voltage. That is your, the temperature of a liquid or oil pressure, right? And all this kind of, gadgets. If you get some of your modern cars, it's just say, hey, here is a speed. You know what? All this kind of even your RPMs, so you don't care because car is automatic, right? Oh, the oil temperature, we're not going to show that. If it becomes bad, we're just going to give you a red light, right? So things kind of like to simplify, because as people progress from kind of, car enthusiasts, right, or somebody who was interested in optimizing, interested in the cars, using them, to somebody who, don't particularly care, right? It's just a device. The car is something what takes me to my grocery store, right? I don't really care about all that kind of stuff besides what I essentially need, right? And I think we have seen also some of the demand for that in the observability space, where I don't think it's completely serviced very well. Then also in the large organizations, we have a lot of silos often. There are different teams, they may have different tools, right, which can be hard to come to the same agreement about state of a problem, right? One team believes the problem is, but then the other says, oh, but we're not seeing anything in our tools. Then, especially when it comes to alerting, we often see a lot of noise. A lot of teams, they say, well, you know what? We want to take a very good care of our system, so we are going to create a large number of alerts, and then, it's always beeping, right? Like your pager or the phone, right, wherever it is, right? And then you can say, oh, but actually 9 out of 10 of those alerts are meaningless, right? And then what? More becomes less because you start to ignore all the alerts, not paying enough attention to them, and then actually often creates the bad outcome. Then there is an overhead. Again, the balance of observability is what you want all the essential stuff captured, stored, and so on and so forth. But if you instrument kind of too much, that can create additional operational overhead. Like debug logs for everything would be awesome, but it's not practical, expensive to produce, and probably even more expensive to store. And then if you look at their problems, and that comes especially with a lot of proprietary cloud solutions, it can get very expensive, right? You may have heard some Datadog horror stories, if you will, right? And people reporting saying, hey, you know what, like 30% of my whole environment spend is going for observability, right? Well, good for Datadog, Splunk, right, and the likes, but not so good for you, right? There, I think you want to make sure that the observability tax, right, which you can think about this way, right, it should not be very high. Okay, so now let's talk about what do we do with Coroot here and how it can help us to solve some of those problems. One is it uses eBPF magic, right? And the eBPF really allows you to get a lot of instrumentation with no code changes, right? Like here is example what Coroot can build using a eBPF and some other tools, right? Hey, we can see what components are talking to what other components, whatever latency distribution out there, what other errors, if anything, right? It can be done. As well as we can look into pull up the data from the cost for common cloud vendors and then provide information about the waste, as well as do some pretty cool advanced stuff, right? For example, we can analyze the traffic between IZs, right, or egress traffic, which can be very big part of a cloud cost in some environments. We also can simply highlight a number of risks, right? And risks are interesting, right? Because risks are something which may not show up in your operations, right? Hey, my system is running well and it's kind of fast and whatever, but when it comes to security or availability, if it bites you in the ass, it can bite you in the ass hard, right? Like if you had a single instance of a database and didn't back it up, right? And then once it's, right, broke down, well, that's maybe a very serious problem for your business, right? Or if somebody once broke into your system, right, and put all your critical customer information out there, right, on the darknet, again, not a very good day for a business, even if it happens rarely. And if it happens, it's also very, very slow to, very tough to fix. With that, let's look into how does Coroot solve some of those observability problems, and again, like how you can even approach that. In terms of hard to deploy, again, with eBPF magic, you can deploy Coroot, right, where it will implement things after magically without any configuration. It can utilize some additional data. For example, if you give it access to Postgres, it will be able to pull up some additional data from PostgreSQL database, but it can get a lot of their main data through eBPF automatically, right? It has a pretty broad coverage of database infrastructure, right? Like, some of the tools which are this sort of like advanced tools similar to Coroot, right? They very much focus on Kubernetes only. With Coroot, it covers everything from, bare metal to containerized deployments. If you think about the problem of hard to use, Coroot was exactly designed with the idea of less is more. We are looking to get less data, less raw data, more actionable insights in this case, which is quite usable in some environment. If you look about the silos problem I mentioned, I think the interesting thing with Coroot is it covers a whole environment, right? It looks at your storage, your network, your database, your application network, right, which can hopefully give you some evidence wherever it is, right, you can all agree on. For example, saying, hey, you know what, we have a performance problem because, I don't know, let's say the storage latency is high. Let's agree on that, and maybe we can use some additional much deeper tools, right, to even go and escalate to some vendor. For example, if you, I don't know, so if your EBS is slow at Amazon, there is little you can do yourself, right? But you can go and maybe complain to Amazon and say, hey guys, that thing, I don't know, let's say every so often it stalls for like a 3 seconds, right? And then it goes and works again. In terms of dealing with noise, the philosophy of Coroot is to look at those most important SLIs, SLOs, right, as well as the critical risks, instead of giving you, you know, vanity ratios, right, what I would call, which a lot of people like to focus on. Saying, hey guys, we are going to alert you when my database cache hit ratio goes below 90%. Okay, so what, right? I mean, it's not very meaningful, at least probably not meaningful enough to wake up in the middle of the night and to look at that. And if you think about the overhead, it's designed with eBPF, which is high performance, and for other stuff it has very heavily optimized and also open source agents. Why is that important, right? Because systems can be very different. You know, sometimes you can say, hey, you know what, I am different and have some outliers. Somebody can say, well, guys, you know what, we have, you know, huge number of requests per second, connection per second, containers per host, right? Number of connections. Sometimes it's going to be very unusual. And if you have access to the source code, it's very easy to say, hey, guys, you know what, we want to restrict this or disable that, which the proprietary solution doesn't provide. In terms of deployment, Coroot is a solution which you roll your own, right? That means it allows you to minimize the cost without having to pay to the cloud vendor, which would have like 5, 10, whatever markup times, 5, 10 times markup, right, on the storage. It has flexible data retention option. It also uses state-of-the-art data storage technology, right? Like we use a lot of ClickHouse, and even you can see in the last couple of weeks, we even have some ability to use hierarchical storage in a ClickHouse, where you can say, hey, I want to store some of my Coroot data in S3-based kind of lower cost storage. Here are some other things kind of to see how you can simplify things with Coroot even further. With a lot of stuff, I think it's very helpful now to get AI to analyze your data and provide you advice, right? But what Coroot makes specific and kind of valuable is, you probably know what advice of the AI, current LLM, depends on a lot what kind of context you give it to, right? Because Coroot understands very well how different things are related, right? It can create that the proper context for AI for analysis and to give you some ideas. It also has some other pretty cool features. For example, one of the challenges which often comes with tracing is how to process those kind of large amount of tracing in a meaningful way. Here we can look into summary, where you can analyze the failing events, right, and then sort of like drill down in a specific sample, which are examples, right? Or another case here, if you have some case of outlying latencies, right, you can go and analyze that, where it will aggregate the traces and see, hey, what exactly in that high latencies, right? What's driving that? Another challenge you may see is while logs contain a lot of very detailed information, it also can be very overwhelming for a system of any significant size. And what Coroot does here, which is I think is very helpful, it can extract automatically repeated patterns, and that typically works sort of very well automatically without some some complicated stuff, right? Where you can see what like the error rate, right, and what specific has been messages, right, which correlate to that, which I think is quite cool. What also is very interesting is what you can use those logs with some alerting, right, which is I think quite classical. But what is interesting is you can also use AI to help you to understand which is relevant and what is not, right? Like for example, in this case, you can have this kind of errors, which probably every system which is exposed to the internet is going to get. Somebody is trying to connect to SSH port, right, with some error messages, right? Well, it's an error, right, but that is not very meaningful for amount of users, right? Probably you don't want to get an alert each time that happens, right? Coroot can get AI suspended, and but where in our case, which may be looking like a similar error message, but that is actually meaningful, then we can see what there's a new pattern which corresponds to basically some serious issue with your databases. So that is there. I think what we are looking at the need to balance in our observability systems with power and simplicity. And I think there are a couple of tools which are important. One, we want to make sure what your observability is complete. Avoid that Swiss cheese of observability and a lot of blind spots. Make sure you have a skill appropriate tools, because again, if something is kind of very complicated, it's maybe powerful, but it's too complicated to use, right? And I think it's also very important to have tools to identify the components specifically. Again, in our complicated environments, right, when you can say, oh, my application is slow. Is it a database? Is that one of the external APIs we're using is failing? Is that network which has some issues? If you have that certainty, right, if you know what that is a database or external API or whatever, right, often from that we can have a tool how to solve it. But finding out exact component which is a failing, I think, is the first thing you need to make sure you have absolutely certainty all the time. Well, and with that, that's all I had for you.